The biggest dump trucks on Earth do not merely break records, as they make previous benchmarks look entirely inadequate. Normal construction vehicles seen on the highway barely warrant mentioning when compared directly to these specialized machines. These leviathans carry 400 tons of rock in a single load. A full-grown elephant weighs about 5 tons, so when a machine at the top of this list hauls 400 metric tons, it equates to 80 elephants moving at once. While you have likely seen large equipment before, these vehicles operate on an entirely different scale. These 10 engineering achievements prove humans will continue building larger vehicles to haul whatever we extract from the Earth. At number 10 sits the Hitachi EH5000AC-3. Hitachi built this enormous vehicle around 2012, and while many know the brand for home appliances, their mining division operates on a vast scale. It carries 326 tons per load, which roughly equals the weight of 65 fully loaded pickup trucks hauled in a single trip. An electric drive system generates power from a diesel engine to spin the wheels directly, operating without a gearbox or a clutch. This system uses electric torque to push over 500,000 kilograms through punishing unpaved mine roads. The Japanese manufacturer built it for sheer efficiency, and the daily operational numbers support this design choice despite the vehicle's enormous size. One spot higher sits the Komatsu 960E. This represents another Japanese manufacturer focusing heavily on raw output. Arriving in mines in 2008, this vehicle packs a 3,500 horsepower engine, whereas a typical sports car produces around 400 horsepower. Komatsu nearly reaches 9 times that automotive output. Stretching close to 15 meters long, it climbs rocky haul roads that stall weaker machines. Carrying 327 tons, it edges out the Hitachi by a single ton, which secures its position one place higher. The list moves from Japan to Belarus, a country well known within the mining industry. BelAZ first rolled out the 75600 series in 2006 to solve the problem of extreme cold in Arctic mines and Siberian pits, where temperatures drop low enough to fracture solid steel. Running an 18-cylinder engine, this giant stands as tall as a 2-story building and hauls 320 tons through those frozen wastelands. Decades of manufacturing experience built into every component keep it moving when other equipment fails. Engineers in Belarus have been solving cold weather machinery challenges longer than most manufacturers have existed, showing heavily in the construction. Germany takes the 7th spot with the Liebherr T 284. Introduced in 2012 with a payload of 363 tons, its most notable feature is its operating speed. A 4,000 horsepower engine drives this vehicle to top speeds of 64 kilometers per hour when empty. Moving a machine larger than a 2-story house at 40 miles an hour requires significant engineering. German engineers solved this by managing how the vehicle handles its own mass at speed to stay stable, where earlier designs would vibrate intensely. That speed advantage translates to more loads per shift, meeting the central demand of a high-production mine operation. Matching the Liebherr capacity at number 6 is the Terex MT6300AC. Terex introduced this specific machine in 2008 with a 363-ton limit. Since it has the same capacity as the Liebherr, it relies on a different feature to separate itself from competitors. This specific model utilizes a heated dump bed where the metal body warms up to prevent wet rock and mud from freezing solid and bonding to the steel in sub-zero conditions. Without that system, crews spend hours chipping frozen material out of the bed after every single load. Across cold climate mines worldwide, this thermal feature saved a vast number of wasted hours that people outside the industry rarely consider. America enters the list at number 5 with the instantly recognizable Caterpillar 798AC. Hauling 372 tons, this American hauler uses the same AC electric drive concept as the Hitachi. Caterpillar built one distinct operational advantage into this vehicle by focusing on ease of repair since mines run continuously every day of the year. A broken truck sitting immobile on a haul road costs maintenance time and chokes the entire operation. Caterpillar designed the layout so mechanics can reach vital service points quickly without struggling with access panels or spending half a shift on a simple job. This combination of reliability and accessibility explains why their machinery dominates pits on multiple continents. The 400-ton capacity benchmark appears on this list for the first time at number 4, with the Komatsu 980E. Unveiled in September 2016, this remains the largest transporter Komatsu has ever produced. The engineering goal focused on building a hauler that perfectly matches the output of the largest electric shovels working in the deepest global excavations. Those large shovels fill the bed in just 3 or 4 scoops, and sizing this vehicle to absorb that specific volume increased site efficiency. Hauling 400 tons per trip up dirt walls requires burning substantial time and fuel on every cycle, demanding rigorous design standards. China entered the heavy truck market at number 3 with the XCMG XDE 440. XCMG looked at the ultra-class market and aimed to challenge the established Western brands. Carrying 400 tons, this machine matches the Komatsu on pure capacity, while including modern features like full LED lighting for night operations and a redesigned driver cab for better visibility. The engineering caters to high-end mining markets across South America, North America, and Australia, introducing heavy competition for Western manufacturers. XCMG created an original design that competes on its own terms, reflecting a current shift in the global equipment market. Number 2 carries a highly recognized name in mining, with the Caterpillar 797F. In continuous service since 2009, this model stands among the most widely deployed ultra-class trucks ever manufactured. A single-block 20-cylinder engine generates 4,000 horsepower, allowing the loaded vehicle to reach 68 kilometers per hour or 42 miles per hour. This speed matters heavily on a dirt road because trucks in a sprawling open-pit mine spend their entire shift driving between the dig face and the dump point. Faster cycles mean more loads per shift, increasing the total material moved and ensuring the mine remains profitable. The 797F has dominated North and South American mining for over 15 years based on this operational logic. The top position belongs to the BelAZ 75710. This represents another entry from Belarus. Revealed in October 2013, nothing constructed since has approached its capacity, making it officially the largest dump truck ever built. It carries between 450 and 496 tons per load, requiring 2 16-cylinder engines working together just to get the vehicle moving. It features 8 wheels instead of the standard 6 found on other mining vehicles, and the empty machine weighs 360 tons. That empty weight exceeds the maximum payload of most trucks on this list, and fully loaded, the total weight approaches 810 tons, rolling down a haul road. Servicing a vehicle this heavy involves replacing tires that stand 4 meters tall and weigh 5.3 tons each. The logistics of maintaining all 8 tires and the dual engines present a complex operational challenge. Parking a fully loaded commercial wide-body airliner on its bed would just about reach its capacity, illustrating the scale of its payload. Share which of these vehicles you would want to ride in for a single day in the comments below, and subscribe for weekly coverage of similar engineering feats. Standard commercial vehicles cannot convey the actual size of the BelAZ 75710. The copper inside personal electronics, the steel in structures, and the fuel in passenger vehicles all originate from raw material hauled out of the earth by machines working in pits large enough to encompass entire city blocks. These trucks operate in desolate places, far from public view, executing the heaviest hauling tasks to keep global industries running.